Lesson 8, line of best fit. So very often when you have data, it looks like this. It's a scatter plot, and it doesn't make a perfect line, but it kind of looks linear. So that's what real data looks like. So when we're doing a scatter plot, we can make a line of best fit based on this data. So what we're going to do is we're going to take a straight edge and we're going to draw a line so that it looks like it's about in the middle of all of this data. So when you draw your line in, just for this example so that our numbers are the same, try to make sure your line goes through the point 10 and 20, as well as 35 and 50, with an intercept of 0 and 8. So this would be a line of best fit. There's about as much data on the one side as there is on the other, so this would be a line that best fits this data. To make an equation for this line, we'd do y equals mx plus b. So first we have to find our m. So to find our m, we take y2 minus y1 over x2 minus x1. This line goes through the points 35 and 50, so we're going to go 50 minus 20 over 35 minus 10, which is 30 over 25, which is 1.2. Our y-intercept is 8 for where it crosses the y-axis, so our equation is y equals 1.2x plus 8. If we wanted to estimate the hours for the kilometers for 33 hours, so our kilometers, are going up and down this way. These are our km and these are our hours. So for 33 hours, if we were to draw a little line on here to represent 33 hours, it looks like it would be about something over 45. So be a little bit more exact on yours with your ruler on yours. Mine's hard to do on the iPad. But we can also use our equation to find this. So we would go y is equal to 1.2 times 33 plus 8 for 33 hours for our x. So this would be 47.6 kilometers. So that approximates our graph. So that was for B. For C, we want to find when you go 63 kilometers. So up here is 63 kilometers. Oops. Probably somewhere around here. It looks like it's about, somewhere after 45. Somewhere in there. So we'll use our equation. So this time we know our y is 63 and our 1.2x plus 8. Now we're going to minus 8 from both sides. So this turns into 55 equals 1.2x. Divide by 1.2, and x is equal to 45.8 hours. So our graph was pretty close on that one. For the next one, we want to determine what kind of shape this is. So if we were to look at this, it looks like it would make a cubic relation. And our reason would be that it has 1, 2 turning points. So you can also have curves of best fit, not just lines of. Okay, a regression function is finding your line of best fit using statistical analysis. So we can find the line of best fit by using a formula, and the formula uses a lot of sums. So this means sum. So if I said E of x, It's not really an E. It means the sum of all your x's. So you would add together all your x values. So when we're doing this, we fill out this chart. We've got x's, we've got y's, we've got x times y, we've got x squared, and then we're going to find the sum of each of those things and use those numbers in a formula. So our x's are the number of shirts. It's our independent variable. So we have 500, 700, 200, 460, and 740. Our y's are the cost per shirt. So 3.25, 1.95, 5.2, 3.51, and 1.69. And xy we find by multiplying those two numbers together. So if you take 500 and times it by 3.25, you get 1625. If you get 700 and times it by 1.95, you get 1365. So what I want you to do right now is pause the video and fill in all of those values. So you should have got 1040, 1614.6, 1250.6. And the last one is your x squared. So you take x and you square it. So 500 squared is 250,000. 700 squared is 490,000. So I want you to pause the video and fill in the rest of those numbers. So you should get 40,000, 211,600, and 547,600. Your last step for filling in this chart is to find the sum of each column. Give us the numbers that we need to use for the formulas. So for the first column, we take 500 plus 700 plus 200 plus 460 plus 740, and we get 2,600. So this represents E of x. So now what I want you to do is I want you to pause the video and find all of the sums of each column. So these are the numbers you should have get. 15.6 is the sum of y. 6895.2 is the sum of xy. And 1,539,200 is the sum of x squared. So now using this is going to find our a and our b values. So we're going to plug it into y equals ax plus b. So first we're going to find a, and for a the formula is the sum of y times the sum of x squared minus the sum, wait, I got this backwards. A is n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x, and that is squared. So now we're going to just plug all these numbers in. Also our n value is 5 pieces of data. So we have 5 times xy is 6895.2 minus the sum of x, which we got to be 2600, times the sum of y, which we got to be 15.6. All of this is divided by n, which is 5, times the sum of x squared, which was 1,539,200, minus the sum of x, which was 2600, and then that number we square. So now we're just plugging this into the formula. So I typed the entire thing into the top, and for my top number I got negative 6,084. When I typed the entire bottom in, I got 936,000. And when you divide the two, you get negative 0.0065. So that is our A value. Now we want to find our B value, so we're going to use the B formula. So B equals the sum of y times the sum of x squared minus the sum of x times the sum of xy divided by n times the sum of x squared minus the sum of x squared. Now we're going to plug in all of our numbers. So the sum of y we know is 15.6. And we know the sum of x squared is 1,539,200 minus the sum of x, which was 2,600, times the sum of xy, which was 6,895.2. And then the whole thing is going to be divided by n, which is 5, times the sum of x squared, which is 1,539,200, minus the sum of x, 2,600 squared. So the bottom numbers are exactly the same. So for our top number, when we type it all into your calculator, you should get 6,084,000. And on the bottom, we have 936,000. And when you take the top divided by the bottom, you get 6.5. So that is our y-intercept. So this is your equation for the linear regression. All right, determine how many shirts he would have to order to buy the shirts for $1.50 each. Is this interpolation or extrapolation? So if we're looking at our data, $1.50 would be in between our data because our biggest data is 5.2 and our littlest data is 1.69. So $1.50 isn't between those numbers. Sorry, did I say they were? They aren't. So this is extrapolation because it's not between the numbers we have for the data, but we can use it to find our answer. So instead of a y, we are going to put 1.5. And then we're going to solve for x. So we're going to minus 6.5 from each side. So we have negative 5 is equal to negative 0.0065. X divided by negative 0.065. And we get 769.23 is equal to x. So Matt would have to buy 769 shirts, probably 770 shirts, to get them at $1.50. Part B says how much would it cost if he ordered 900 shirts. So 900 would be on here. Because our biggest number is 700 and our lowest number is 200, this would also be extrapolation. So we go 900 for x, so y equals negative 0.0065 times 900 plus 6.5, and you type that all in, it would be 0.65. So it should cost about 65 cents per shirt.